Cool. So, welcome to week four, day one. We're going to talk about networking, uh, more physical networking. We're going to talk about how that conveys with cloud networking. And then we're going to talk about Route 53 if there's time. And then we're going to do some diagramming today. So, let's jump into this lesson. There is going to be a lot of reading. So, I'm going to ask that everyone participates. If I can get everyone to read at least once, that'd be cool because there's, once again, just a lot to read today. So networking in like simplest terms is like computers connected to computers, right? Why would they do that? It's because they're sending and receiving information. You may not be familiar with it, but networking is everywhere, and you've definitely have seen it in one context or another. For now, we're just going to go ahead and read some of this. So essentially, network refers to the practice of connecting multiple devices together in order to share resources, exchange data, and communicate. Essentially what we said. Right now, we're going to do an overview of these. Not each one, but we are going to start with LAN. So just for reference, here's just a diagram, which is cool to see that this does classify as a diagram. But towards the end of the day, when you go back to this, you're going to say, wow, what a terrible diagram. So we'll start with features of a computer network. Could somebody, oh, real quick, with these features of a computer network, these are all the features, but I did break them down into their three groups. Essentially, the first are primary functions. Next, they are infrastructure focused. And then the seven and eight are nice to have. They're normally found, but they're technically not critical to have a computer network. Could I have a volunteer to read the primary functions?
One, connectivity. A network allows multiple devices to be connected and communicate with each other. Two, sharing. Network allows devices to share resources such as files, printers, and internet connections. Three, communication. Networks enable devices to communicate with each other using various protocols and technologies, such as Ethernet, Wi-Fi, and Bluetooth.
Cool. So yeah, so these primary functions is essentially the definition, right? Like we said, they kind of need to connect, they need to share, they need to communicate. It's essentially that's the definition of it. That's why it's their primary. Could I get a volunteer to read infrastructure focused?
Infrastructure focused, scalability. Networks can be easily expanded by adding more devices or upgrading existing hardware and software. Security. Networks can be secured using various measures such as passwords, firewalls, and encryption to protect against unauthorized access and data breaches. Centralization. Networks can be figured with a central server or network device that controls access to resources and manages network traffic.
Cool. And can I have someone read the nice to haves?
Nice to haves. Efficiency. Networks can increase the efficiency of communication and resource sharing by allowing multiple devices to access shared resources simultaneously. Flexibility. Networks can be configured in a variety of ways to suit different needs and requirements.
Cool. So what we're going to talk about now are types of networking. Because now you have the concept of what it is. Essentially, each of these types, and to a certain point, the only real difference is going to be the scale. So we're going to start out with the smallest version, which is a wireless local area network. Here it says these are networks that use wireless technology, such as Wi-Fi, to connect a device within a small area, such as a home or small office. So essentially, probably everyone in this room has a wireless local area network in their home that you've interacted with every single day. You just didn't know. Right there is an example of a network. So this is a diagram that does represent that, just on a radical scale with more devices. A local area network is a little bit larger. Could somebody read just these two sentences or two chunks?
There are networks that are confined to a small geographic area, such as a single building or a group of buildings. LANs are typically used to connect devices within a small organization, such as a business or a school. In this diagram, the LAN consists of multiple devices that are connected together using a router. The router allows the devices on the LAN to communicate with each other and devices on the other networks, such as the internet. Devices on the LAN can include computers, printers, and other types of networking equipment.
Perfect. So exactly. So we started out with kind of just like in your house, you have your phone connecting to your router that connects to your modem that goes out to the internet. And then here with the LAN, it's just a little bit bigger. It's essentially the same thing. But now you could expect it, like it says here, within a small business, within a building. So we're going to go up the scale just a little bit. A metropolitan area network. Could somebody read this? And you could just read these first two chunks here.
Metropolitan
Uh,
area network. Oh, go ahead, sorry.
no, go ahead.
A metropolitan area network is a computer network that spans a metropolitan area connecting multiple local area networks together. A MAN is typically larger than a LAN, but smaller than a wide area network or WAN. MANs are often used to connect the LANs of multiple businesses, schools, or government agencies within a metropolitan area. They can also be used to connect the LANs of multiple buildings within a large organization.
Yep. So once again, we're continuing this pattern, right? We went from in-home to in-building to now essentially citywide, or what could be citywide. And one of the cool concepts that was mentioned here is that it's not like, oh wow, what kind of crazy technology are they using now? It's essentially just using multiple LANs and actually connecting them together. Because remember, networking is just that connection point. But now instead of connecting a device on a device, now it's connecting an entire network to an entire network to make up that larger grid. Then we have a wide area network. Could someone read just the first sentence?
These are networks that cover a larger geographic area,
No,
such as a city, a state, or even an entire country. WANs are often used to connect devices in different locations, such as branches of a company or different offices in a city.
Perfect. So exactly, once again, scaling up now, as large as you can imagine in a sense is kind of where that's at. So here's the thing. Now we have virtual private networks. We're no longer scaling up. Now we're kind of just moving away from physical to non-physical, hence virtual. With this VPN, could someone read this one chunk?
a VPN is a technology that allows you to create a secure connection to another network over the internet. VPNs can be used to access region-restricted websites, protect your browsing activity from being tracked, and more. VPNs are often used by businesses to securely connect employees working remotely to the company's network.
Cool. Yeah, so VPNs, I'm pretty sure most of you have used this. Has anyone used a VPN for a use case that may not be as like commonplace as like, I don't know, what hiding browsing activity or like region restricted? Are there any other use cases that aren't listed that may not be as well known?
Well, I don't know. I mean, I use a VPN all the time. That's mostly because I'm a little paranoid, though.
Oh, so
So is
you,
that a reason?
yeah, that's a paranoia is a reason for anything. No, but in your case, essentially, you're just trying to mask your IP then, is that correct?
Yeah, I mean, kind of, sort of, though, because that, well, okay. So another good valid reason is that sometimes there's content that's limited by geographic region. So
Mhm.
I sidestep that by using a VPN.
Okay, right on. I remember when I was in France, I was doing study abroad. I was getting kind of like homesick because Lyon reminded me of New York a little bit, of like just kind of a city. And then I was kind of like missing English, like just kind of hearing it. So I remember using a VPN to access Netflix, but in the American geo, so I could watch Broad City. That was that's my VPN story. But cool, thanks for sharing. So aside from VPNs, can someone talk about a cloud network? And then this one's going to be pretty relevant. So if you could read that first chunk.
A cloud network is a network infrastructure that is built and operated by a cloud provider and made available to customers on a pay-as-you-go basis. Cloud networks allow customers to easily and quickly deploy and scale their applications and services without having to worry about the underlying infrastructure.
Perfect. So a lot of people know about cloud or know about cloud providers such as like GCP or AWS. And this is what it's referring to, except instead of the whole platform, it's kind of referring to like a little slice of it, the slice that you can use. And then we're going to kind of jump into this in another word, and that's going to mean essentially the same thing. So here it does talk about components of cloud networks, shared service model, and working. I think we can skip this because it's essentially what I just described, but in more steps. It's just kind of like your slice of heaven, if you would. Here we do have the same network types that we just talked about. But here it just shows a little bit of the differences. So the one that we already know that I think we've beat to death here is the geographic scope from smaller to larger. With that, here you can see the increase in size that it can handle. Cost, obviously the cost is going to scale with the speed and the size. And then here are just example use cases, but they're essentially, what we mentioned, so we don't need to read each one. And then here, once again, we probably won't go through this, but it's just showing the comparison between the area networks, which are the physical. So if you see area networks, just know they're the physical versions that we described, versus a VPN versus cloud networks. This isn't super relevant for this course. Specifically, you can read this if you'd like, but maybe we'll skip that for now. VPC, this is where, this is more important. Virtual private cloud. So this is essentially a cloud network. Well, not essentially, it is a cloud network. So what the difference is a VPC is like branding, and this is what you'll hear when you're specifically using AWS. And if I'm not mistaken, I think GCP specifically uses that as well. So on AWS, when you use your VPC, your virtual private cloud, once again, you're accessing their platform, the Google Cloud platform or the AWS platform, and you're just kind of getting your piece of that platform. So instead of having to build your own area network, for your company or whatever, instead you can just access their cloud resources. One of the cool things too is like the cloud's not magic, and that's important. So you don't need to specifically know how the cloud works, right? That's kind of the privilege we have with a lot of technology. But know that it's not magic, and instead it actually is area networks. The only thing is you don't have to worry about it. So to you, right, to us, it's actually just that VPC, it's that virtual private cloud, and they take care of the rest. So here are key takeaways. Could somebody read through this? Yeah, just read through each of these, which is just the VPC versus the traditional LANs.
Think of a virtual private cloud as your own private virtual office network, infinitely scalable and managed online. A VPC is equivalent to the Office LA LAN, your entire private network, but virtual instead of physical. Subnets are equivalent to office rooms. These divide your VPC into smaller, isolated sections, just as you'd use rooms to divide an office. Routing tables are equivalent to routers. These are the digital rulebooks that decide the best path for traffic to move between subnets, serving the same purpose as a physical router. Internet gateway, or IGW, are equivalent to the front door. This is the gateway or reception desk for your network. It is the entire entry and exit point that connects your VPC to the outside world, aka the internet.
Cool. So yeah, so this is essentially just kind of showing you like the equivalent of the virtual aspects that you're using and kind of how they relate to more real life concepts. So it should just be more digestible. So right now we're going to go off of network topology, but we're not going to really go into it in detail. We're just kind of look at it briefly and kind of get the concept. And that's because we're not really dealing with hardware, right? In this course, we're just dealing with the cloud. But for now, could someone read this first portion? And we'll probably skip some of the other ones.
Bus topology. In a bus topology, all devices are connected to a central communication channel called the bus. The bus is a single cable that runs through all the devices on the network. Data is transmitted along the bus and is received by all the devices, but only the intended recipient processes the data. This type of topology is simple and inexpensive to implement, but it is not very fault tolerant. If the bus fails, the entire network goes down.
You can kind of think of this as like old school Christmas lights, where if like one of those lights burn out, the rest of the stream dies. That's how I think of it. There's this enhanced version. There's a star topology. Someone could read this one.
In a star topology, all devices are connected to a central hub or switch. The hub or switch acts as a central communication point and forwards data between devices. This type of topology is more reliable than a bus topology, as the failure of a single device or cable does not affect the entire network. However, it is more expensive to implement and requires more cables.
Cool. So here we just kind of look at the shape to get the concept of this. So here's a ring topology. And then if we go down, you see the mesh. where everyone can connect with each other. It doesn't have to go through kind of like this reminds me a little bit of a actually I don't know if that's accurate. I was going to say it reminds me a little bit of a decentralized system. But actually I'm wondering if this is more of a decentralized system. So, yeah, I was kind of looking at it now. But we're going to go past that for now. There's the tree topology, which is, if this looks familiar to you right here, it's the star topology, but it's actually connected through the bus. So it's kind of a mix of the bus topology with a bunch of stars. So that's an easy way to remember the tree. And there's also hybrid. And this isn't necessarily what a hybrid looks like, because a hybrid can technically be anything. Anything is not one of the ones we mentioned, which is a little hypocritical, if I could say so myself. Because if you remember, isn't this really just star and bus? So technically the tree topology is a hybrid. However, it has its own name, and any other configuration would be a hybrid that's utilizing, one or more of those, or excuse me, two or more of those aspects. So the question here, okay, yeah, this is just comparing the pros and cons, but we'll skip that for now. The question that you may be asking is like, hey, if we're not dealing with physical, right, and we're going to jump on the AWS, bus and learn about actual cloud and, having our own VPC, what's the connection? So it's a concept of like physical versus logical. Here it says the network topology mentioned and their data structures reflect physical world connection options, right, which we already know. When using a VPC, you're constructing a similar design using the logical aspects. So I added this footnote. It's not a one-for-one. It's not to say, oh, hey, here's the physical. How do we construct this via code in the sense of saying, oh, build each of these steps as you would. It's more of a logical similarity that's enforced by the software rules. So it's like reconstructing physical into conceptual. So here's an easy way to understand it. With physical topology, which is all of the area networks that we went over, or excuse me, not area networks, the topology, what's a good way to call them? Structures, I guess. Let me see how we labeled them here. Yeah, network topology. It's more boring than I thought. So this is an aspect of like the network topologies if we're using physical devices, right? You can think of it as a city street map. So this is a physical layout of every single road, overpasses, underpasses, one-way streets. So it's the cables. You can't change it without a construction crew, right? So it's like physical foundation. With logical topology, think of it as if you were designing city bus routes on top of the street map. So you have to decide, how is traffic going to flow through the streets, right? You may have two ways to do that you construct. You could say, oh, well, what if we have a bus route A? And we're going to use the concept of a star topology, right? Where you can design a bus route where all the buses, we'll call those spokes, right? Or representing spokes, where they have to go to the central bus depot, the hub, before going to their destination. So if you remember the structure of the star topology, this is the same exact concept, but instead of using computers and cables, we're using it to map out how the buses will interact with their hub. Let's say, for example, we made another route, we'll call it Route G. All right, we can use that mesh topology, excuse me, where you can design an express route that connects two popular neighborhoods, neighborhood A and B, or VPC A and VPC B, without going to the central depot, right? So it's this, once again, just the same physical concepts, but we're now applying that connectivity logic into something else that isn't networking. The reason that's important is because once you create your VPCs, you can kind of do the same thing conceptually, right? So they're kind of just strategies of connections, if you would. Could somebody read this?
How this maps to a VPC, physical reality that you don't see. Somewhere in an AWS or Google or Azure data center, there is a giant hyper complex physical mesh of thousands of servers and network cables. This is the city street map. You have no control over it, and you don't even need to see it. Logical reality, what you build. Your VPC is your own private section of that city. Your routing tables are the bus schedules you write. Your transit gateway is the central bus depot you build.
Cool. So yeah. So essentially what we're talking about, right? That whole physical concept that we no longer have to worry about. That's all happening in our concept of the cloud. But the cloud is kind of, just think of it as your peace of mind. And you could say, hey, anything of how it's working doesn't really affect us, right? So what is important is this, the logical reality of what we build. And once again, we can use physical concepts and use them in an abstract way to create that reality. So in terms of the basics of networking, this is it. This is what we're going to get out of the class today. There's two other lessons here, though. If this back button actually works. That's weird that it threw us into this Route 53 in records. Okay, so I guess we're going to do Route 53. I was going to say maybe we'll jump to the diagram portion. So what is Route 53? It's an Amazon service. So this is one of the ones that you have to know for your test and or your cert, but also you are going to utilize it in future labs. So Amazon Route 53, highly available and scalable domain name system. It's a web service provided by AWS. It's designed to give developers and businesses a reliable way to route end users to internet applications. So here's some key functionalities, which look like they should have been broken down. But it deals with domain registration, DNS management, routing, traffic routing, and one more, yep, and health checking. Real quick, some of you may not be familiar with DNS. So here's the too long didn't watch in this video. We are going to watch it because it's really quick. It's only 100 seconds. But what's a DNS, right? Because it's hard to figure out like Route 53 if you don't know what DNS is. So DNS is a phone book of the internet. It translates human domain names to IP addresses, so packets know where to go. So essentially, anytime you type in any URL and hit enter, right, codeplatoon.com, it has to, that whole URL has to get translated, and then it magic, if you would, right? That's the DNS. But to explain it better, here's DNS in 100 seconds.
The domain name system, or DNS, is like the phone book of the internet. It maps human-readable URLs or host names like www.fireship.io to the IP address of the server that hosts that site. When you type a URL into the browser, it makes a DNS query to figure out which unique IP address is associated with that host name. First, it'll attempt to look in the local browser or operating system cache, but if the cache is empty, then we need to look up the IP address in the phone book, which is the job of a server known as the DNS recursive resolver. It's recursive because it needs to make multiple requests to other servers, starting with the root name server, which itself will respond with the address of a top-level domain DNS server, which stores data about top-level domains like .com or .io. The resolver makes a request there, which will respond with the IP address of the authoritative name server. That's the final source of truth that contains the requested website's IP address. That gets sent back down to the client and is cached for future use. That sounds complicated, but it all happens within a fraction of a second. You can think of it as a globally distributed database that handles more requests than any other database in the world. When you register a domain name, it's handled by a registrar accredited by the nonprofit organization ICANN. The record is then maintained by a registry operator who stores your DNS settings and propagates them to other DNS servers around the world. As the registrant, you'll be assigned a zone file where you can configure the settings of your domain. Every zone has a start of authority record to tell other DNS servers who's in charge of that domain. But most importantly, we have the A record. It means address and maps a domain or subdomain to the IP address of its host. In other cases, though, we may want to forward a domain to another domain on the internet instead of an IP address, in which case a canonical name or CNAME record would be used. We have MX records for email, and we can store arbitrary data with text records, which is often used to communicate with third parties to verify ownership of the domain. And finally, we have the NS or name server record, a URL that the internet can ping to find our IP address, and there's almost always two of them for better reliability. This has been the domain name system in 100 seconds. Hit the like button if you want to see more.
Cool. That's a lot to throw at anybody. Usually, if I want to know what something is, I'll kind of like, I will search YouTube and I'll search if there's a 100-second version because it's like a really good high level. And for me, at least, it's really good to just kind of like absorb as much as I can. And then as I'm like reading through the docs and stuff, a lot of it just kind of feels familiar. So I don't know if that's helpful. Could someone read? Oh, well, we went through this. So I'll go through these common use cases of Route 53. Hosting websites and web applications, load balancing across multiple servers, implementing disaster recovery with failover routing, creating custom DNS configurations for hybrid cloud environments, managing multiple domains and subdomains for a central location. Quick analogy, if the internet is a city, Route 53 is the GPS system that tells traffic, your users, how to get to your building, your application. I'll just read that portion. Here's some notes on pricing, but it's not really so relevant for now, so we'll skip that. How DNSs work. We just watched the 100 seconds, but if it was too fast, here it is. So users type their URL in the browser. Browsers ask DNS resolver, what's the IP address for, whatever.com? The DNS resolver queries the authoritative DNS server. This is where Route 53 comes in. Just heads up. So Route 53 responds with the IP address based on the configured records, and then browsers connect to the IP address to load the website. So here are some DNS record types and what they do. Could I have a volunteer to read each of these? Or if you get bored, at least just read up to the MX and I'll have someone else read the last three.
DNS record types. A record, address record, maps domain to IPv4 address, e.g. example.com, to 192.0.2.1. Quadruple-A record, address record, IPv6, maps domain to IPv6 addresses. Quadruple-A, it is called Quad A, because IPv6 addresses are 4 times larger than IPv4 addresses, 128-bit versus 32-bit. So it gets 4 A's instead of 1. CNAME record, canonical name record, maps domain to another domain alias. MX record, mail exchange record, directs email to mail servers. NS record, name server record, specifies authoritative name servers for domain. SOA, start of authority, think of it as the official birth certificate or administrative file for your entire DNS zone. SOA is not a selectable record type. It is created by default. TXT record stores the text information, often used for verification.
Cool. Thank you. So for these record types, the good thing is through Route 53, you don't have to remember, like if you're setting these up, you don't have to remember what each of these does. And the reason is when you go to select them, and if we have time, we will do the walkthrough for it. When you go to select it, it actually gives you the explanation of what each of these are. So that's always good. And
I have a
then,
quick question if
sure.
you have a second. So I manage my domain name like via Wix.
Okay.
So does that AWS have similar, I assume it does. Is Route 53 like their version of like where you can buy a domain and then manage your CNAMEs and manage, like adding the different, I think sometimes I've had to add a CNAME anytime I want to add a subdomain. Is that Amazon's version of that?
So actually, a good question is if someone could answer the one portion specifically. I'm not certain if you could purchase a domain name specifically through Route 53. If anyone knows, please shout that out.
Or is it only like managing or?
Yeah, because as far as the use cases that I've seen, it's managing. So you'd still purchase it on like Wix or 1&1 or whatever, and then you would just use that use their Route 53 as like just kind of like the big boy to kind of handle everything as we're discussing, and then to initialize these record types. And then you could even do it on the Route 53 side. And give me one moment, I'm just going to close the door real quick. Okay, solid question. Since no one jumped on the Route 53 thing,
I
I'm
was
going to
going to
assume that
say
you can't purchase.
internet's saying you can purchase through
Oh,
Route
you can
53.
purchase.
Yeah,
Okay.
you go log in, search for the domain, click check to verify its availability, and then it says proceed to checkout. So
Okay,
it's
cool.
making an Amazon purchase for the domain.
Yeah, right on. Actually, one of the things too that's interesting, because like I know like I'll use like Vercel and stuff when I'm using Next.js for the front end, and you could purchase a domain through there, which makes it like super easy to configure because it's like all one system. So I assume it's just the same. But a lot of times the domain purchases are more affordable if you get them through a third party. So like depending on like if it's $1 or something, it usually doesn't matter. But sometimes domain names can get very expensive. So I would say if just kind of shop around, and sometimes it's worth to do more configuration just to save the money. So one of the things we're going to look at as well that Route 53 can handle, in addition to the record types, it also handles routing policies. I'm trying to see how much time we have. 15. Oh yeah, let's go ahead and if I can get a volunteer to read through these.
Simple routing policy. Use for a single resource that performs a given function for your domain. For example, a web server that serves content for the example.com website. Simple. Failover route policy. Use when you want to configure active, passive failover. Geolocation routing policy. Use when you want to route traffic based on the location of your users. Geoproximity routing policy. Use
Actually,
when
if
you
I
want to
can,
route
Justin,
traffic based.
if I could stop you, I appreciate you. I don't think we need to read through all of these, so I don't want to torture you. And one of the good things with these is you don't have to remember each routing policy, because just like the name, or excuse me, the record types, Route 53 is going to give you the definition of each one, and so you can you just don't have to remember anything anymore. It's kind of the thing. So I think we have just enough time to show how to set this up. So if so, let me see if we can do this real quick, because it actually doesn't take long at all. What we're not going to do, obviously, we're not going to purchase a domain, but I was hoping to. Here, hold on. I was going to put this over here so I could follow the steps on my left side. I mean, actually, it's here. We'll just create one. So create a hosted name. Let's say we did test1.com, right? So here we put in the domain name. Actually, I'm sorry. You know what? When you go to Route 53, on the left, make sure you're in hosted zones. Any hosted zones you already have will show up in this list. If you want to create a new one, right here, you go create hosted zones. Here, where it says domain name, just whatever, we'll do test1.com. For the description, it is optional, so we'll skip it. For the type, there's public and private. I would assume 99% of the time you're going to click private. Or I'm sorry, public. Here, the private one, it says a private hosted zone determines how traffic is routed within an Amazon VPC. So this is kind of like, to me, like more internal. So you click on public, and this is it. Actually, I can't see the bottom here. Let me move all of the Zoom UI out of the way. Let me put this to the left side. Okay, and then right here it says create hosted zones. So once we do that, we'll get put back right here. We can go back to the hosted zones, and we'll see the old one and the new one. Within this hosted zone, what we can do is, you guys may remember this, right? From the list of the record types, if you remember SOA, this is start of authority. This is created by default. This is the NS record, which is the name server record, obviously also created by default, but we can create our own. So if we click on create record here in the top right, we can name it whatever we want. But what I do want to show you is just really these. So if we go to record types, remember all those records, like there's even more here. It tells you what they are and exactly like what they do. So that's why I was saying you don't have to remember anything anymore. But let's say we wanted to create the quad A. You can specify here, it's like a cache, the TTL, it's time to live. The quicker it is, the faster your site essentially refreshes because it's a caching system. The longer you have it, the more stagnant it will be. Here with the routing policy, you should remember we went over this as well. Oh, that's interesting. I misremembered. No, I didn't. So here it shows what each of these are, right? But it doesn't have the definition. But if you click on info, here you go. It tells you what each of these actually do. And that's why I was saying you don't have to remember it, but these are the same things that we just saw in our notes. So from here, let me see if we can just create this without filling in everything. Here's what I'm going to do for time. I'm not going to fill these in, but essentially just put in the values, put in the records, create the record, and then it's just going to show up here in your list. I'm going to go through and just delete this real quick so I don't forget. Also, just a little disclaimer, when using AWS, everything costs a buttload of money, even when you're not using it. Things are still like running. So if you're not using stuff for projects, make sure to remember it. Remember to delete it. And that's just a disclaimer, especially once we start getting into the AI stuff, that cost is going to shoot up. So just make sure, you guys are deleting stuff. All right. So that's essentially it for our demo today for this Route 53. What we're going to do now, though, is jump into the diagrams. Okay. Here's the thing with the diagram, right? I have this video. How much time we got left? I'm going to show you this video, and then I'm going to ask for someone who's never seen it to tell me what they believe is happening in this video. All right. So my question is, who could tell me what's happening in that video?
They're finding resources and use on the AWS web service.
I'm seeing keyboard warriors.
Whoa, let me ask you guys, did you guys see that video?
No, I was making a joke.
Oh, okay. It's because then someone else said something random too. But yeah, so could anyone tell me what happened in that video?
Two dogs were aggressively barking at each other through a fence. Once the fence was exposed, both of them backed down, and then once the fence was closed again, they started back.
Sure. Can I ask you why?
Because animals, including dogs, just like people, will act a lot tougher when there are no consequences for their actions versus when there are.
So that's a solid guess, and it could be correct, right? We can't say in the instance of every dog interaction exactly what's happening. But essentially, there's something psychologically happening here. It's called barrier aggression. It's also called leash aggression. They're interchangeable. Essentially, one of the reasons it could be a lack of social. It could be. But usually what it is you have, like, these dogs want to communicate with each other, right? Dogs get to know each other. They communicate by like interacting, by having visual cues that humans don't really process the same way, by smelling each other, right? So when there's this barrier in between them, that act of aggression isn't actually aggression towards each other, which is why once the gate opens, they stop. It's an act of aggression, let's say an expression, because they can't communicate, right? So it's frustration caused by a lack of communication. One of the reasons I show that is because I feel like with humans, we actually do that a lot. Like if you ever try to explain something to somebody and they don't get it, you're like, what? You don't get it? But also you've been on the receiving end. Someone tells you something and you don't get it, you get frustrated as well, right? So the reason that this is relevant is because right now we're going to talk about diagramming. A big thing with creating diagrams is it's a way to express something in what should be a digestible way. So it helps prevent that frustration from having to explain these abstract concepts, and it helps prevent the frustration from someone having to understand them. So essentially, a diagram is a form of communication. One of the things when you're planning your diagram, right? So just heads up, from here on out, we're just talking about diagrams, right? So whenever you're planning a diagram, you have to consider simplicity versus complexity. But in reality, this is no different from any time you're communicating with anybody, right? You have to know your audience. You have to know usually their background knowledge. And there's that concept called technical communication, right? So if you're talking to a 5-year-old or talking to a 10-year software engineer and you're going to tell them about your app, let's say, right? I assume you're not going to tell them the same thing, right? You're probably going to tell the engineer more of like, oh, the tech stack and this and that concept and efficiency, whatever, right? You might tell the kid, oh, hey, there's this app that lets you talk to people, whatever app you have. This is essentially the concept we're going to talk about today because here is a diagram. This is a real diagram from Slack. We can look at it. This is about should we send a notification? We're not going to go through this whole decision flow, but this is like pretty complex, right? If we take a moment to look at it, I'm sure we'll understand it. I think everyone here is intelligent enough to understand this flow because it is made for more technical. But also it's a little bit of a closer view of what's happening, right? In another sense, someone can express a notification system like this, showing a little bit more of like, just kind of taking that step back and showing more of just the big pieces instead of every literal step. This is a very important concept. Let me see if it's this next portion. Oh, okay, we'll get to this next part. So essentially here, it's saying that a problem that a lot of students have, right? Because a lot of our students are extremely intelligent. I'm sure all of you know that just by talking to each other. And kind of what happens is like a lot of people that are in computer science are very like rational and logical. Like A equals A and B equals B. And sometimes it doesn't, man. So what it is like sometimes when you're communicating, whether it's a diagram or whatever, here it's saying it's just more art than science, right? So I have if you guys seen Rick and Morty, sometimes science is more art than science. A lot of people don't get that. This applies to everything, but it does apply to diagrams. Let me ask so far, just off of this conversation so far, is this conveying, or am I not technically communicating in a way that's appropriate?
Yes, you are. It's spot on. Know your audience.
All right, cool.
Yeah, I appreciate your dog analogy too.
Oh, okay. Cool. Yeah. I wasn't sure if that one was gonna hit. So
that was good.
Cool. I added it this morning, actually. I was doing a prep and I was like, wait a minute, I remember this video. And I threw it in. All right, cool. So in the same vein of what we're talking about, when creating diagrams, there's a C4 model. And it's a systemic way to design. So there's four C's, right? C4 model. Context, container, component, and code. What you can think about is like the context version is sort of like that bird's eye view of the city, right? Like this huge, like what they call high level. I'll say this is one of the things that tripped me up in software engineering or just computers in general. High level does not mean, ooh, higher caliber. It actually is just a larger overview and less technical. And then as you get smaller in, then it becomes more technical. So same thing with these diagrams, right? You can start at the context level. This shows the overall system architecture and how components are interconnected. At the container level, right, we're taking one step closer. It's focused on grouping high-level building blocks within the system, such as servers, databases, and APIs. Get one step closer with the component level. You could break down containers into smaller parts like services, classes, and modules. And then you can go even deeper, show the actual code. Zoom in, show actual classes and methods and functions. This is all part of technical communication, right? So here it is in the aspect of, how do you create a diagram? But it's also in the aspect of knowing your audience. If you haven't worked in the professional like tech field, one of the things you'll see a lot is like there'll be like these super long company meetings, and they always start out at that high level, at the context level, because of the stakeholders and all the non-technical people. And what happens is like as these super long meetings go on, the stakeholders will drop off. And then the next level of like less technical people will drop off. Like, so essentially as you're getting deeper, you're going to get a smaller audience of more technical people who need to know. And so that's just kind of a good way to structure things when you're being time conscious, or just once again, just knowing your audience and just choosing the specific aspect. So here's actually a really cool, like, this is a little hard to see, but it doesn't matter because we're going to click the link. So this is just kind of showing you the overview of these 4 C's, which is what we talked about: context, containers, components, and code, right? There is Oh, is there not a link? Oh, you know what? The link is hidden. So if you click on the C4 model, it will take you to the site. This is specifically already in the diagrams. And if you click here on the left, here's an example of the context, right? It's super high level overview. You go in one side deeper, you're in the container. And we're getting a little bit more. I'm just not going to read through each of these, just kind of like see it visually just to get this like concept. The component level, we're getting deeper. So just to clarify too, deeper doesn't always mean more in terms of visual. It's just more technical, right? It's lower level. And then the code diagram here, and I'll show you this one because it's the most different. So here it's actually just showing you functions. So this one's not technically showing you the code, and in this one, it's actually just showing you the functions that are being called. Give me 1 second. Okay, cool. So yeah, so that's essentially that. And then you can click on this because your assignment today is going to be to create a diagram. Well, create, I think, 3 diagrams. So you can always refer back to this. And then essentially what makes a diagram good, right? So we already we already talked about communicating, right? So it's essentially kind of the same thing. So clarity, use consistent symbols and labels to ensure that every component is understandable at a glance. Layering, show how resources interact across layers, application tiers, or network tiers. The flow, indicate how traffic moves through the system using arrows and labels. Annotations, provide context like subnets, IP ranges, and security group roles. Scalability, keep diagrams flexible enough to accommodate future growth and changes. This one kind of seems like it's the dumbest, I think, but it's absolutely not. And the reason why is whenever you're creating a diagram, don't think of it as this static thing, hooray, I'm done. Think of it as this like living, breathing part of your documentation. Because even if you're like demoing a document, depending on the audience and the type of level that you're doing, right? People are going to have input. People are going to say, oh, wait, did you include this? That is important. You'll be like, oh, yeah, now that you mention it, you're right. It's an important part of the flow or it's not. Or once again, even as things change, you're physically going to go and change it. So think of whenever you create a diagram, for the most part, think about it as this collaborative, visual that people are going to have input on, and that is going to change over time. So make sure it's scalable like everything else that we do. Let me see here. Actually, question, or no, I thought we had another. Yeah, okay, it's at the bottom. This is essentially the same thing. I mean, this is just kind of like another version of a diagram, but showing it within like AWS. So it's like, hey, here's your instance of an EC2, which I believe you guys have already utilized. Inside of the EC2 has some internal components, right? AMI, you got all of this. Like I said, I think you guys already did this, so I'll know my audience and skip ahead. For your bucket to hit, your EC2 and your bucket to hit, here it's going to go through these permissions. So essentially what this is showing is like, in this case, the permissions is sort of like the hub, and everything's going through it to check before it hits the EC2 instance. And then even on the way back, it's going to check it again, right? So this is just a diagram, just another visualization of it. My question for whomever would like to answer it, just looking at this diagram, can you tell me what's going on?
So what you have, I guess, is the cloud, which is located within a certain region. And then I'm assuming traffic is flowing through an internet gateway. And that same traffic, which is an entry point to the VPC, virtual private cloud, and then it's maybe being routed to different instances or subnets of that VPC, different availability zones.
Yep, exactly what it is. So like you said, cloud, region, hitting that gateway is going to 3 different subnets. Each subnet is in its own availability zone, which I thought we had the definition of availability zone somewhere, but if you're not familiar, actually I think we talked about it, but it's essentially just databases in different geographical regions. The whole reason for that is like if there's like some sort of weather emergency or whatever and those servers go down, your site's still alive somewhere else. I don't know much about the recent AWS outage. I was waiting to get more information, but I was surprised because they have these availability zones. But anyway, the point of this whole map here was that we were able to just look at it our first time and understand what's going on. So I mean, I think this is still a solid example of a diagram.
That's when we select like Virginia or Ohio or Oregon, right?
For the region, yes, that's exactly what that is. Yeah. Well, actually, no, that's your region. If you're going to do availability zone, it's kind of like now choosing alternatives. But yeah, so you still have like your one region, and then you'll have those additional alternative zones that have duplicates of your databases. And then here we already talked about what VPC is. It's like your own slice of heaven, if you would, within the cloud. We'll skip that for now. I'm not really sure why that's here. I guess the whole point of this is just show you different diagrams. So then here we have a VPC diagram, which is once again the cloud. Same thing. Can someone look at this and tell me what's going on here? And I'll scroll down so you can see the rest. And notice it got a little more crazy. So essentially with this one, it's the client browser. A lot of times that you create diagrams, not always, but a lot of times you're going to kind of start at the client side. It depends on what you're doing, but it kind of helps, in my opinion, it helps the recipient of the diagram. It helps them kind of understand the flow. Because like sometimes, for example, right? So here, you're going to start at the client browser, which is just some dude on a computer or phone, whatever, right? Here it's going to do a DNS lookup. You guys know what that is, right? It sends it to Route 53. Then it's going to send the HTTPS request. And then that's going to hit the virtual cloud, right? Now, we kind of went over this. You guys should, get this quick flow already, right? Like, just know what it means. But here's the question. What if you had just started it like right here? Like let's say you started it at the VPC level, right? Now, you guys as engineers, you can just infer, like, yeah, obviously someone had to trigger something, right? And, oh, if it's AWS, they're probably using Route 53. But the thing is, most people wouldn't understand that. So then now this is just kind of like an island, right? And they'd say, what the hell is this? How did you get here? What's the context? And then just by adding just this little bit here, you've kind of explained the context of at least how to get here. And then once they look through this, they may be able to infer some more. So that's just kind of something to consider, but we won't go through this whole thing here. All right, so let's talk about diagramming tools because you've seen a few examples of them. They all look different because there's no set standard. Remember that whole thing? Sometimes it's more art than science. That's also literal with that diagram, right? The colors, the fonts, the sizing, shapes, whatever you want to do, right? There's a bunch of different tools here. Figma is pretty solid, but it has the steepest learning curve. So this is actually not meant as a diagram tool. If you're familiar with Figma, it's actually more for websites, like UI, UX engineers will create visuals of websites, and then they send it to the engineering team. I was hoping they had something better here. Yeah, so see here, it's all about like design. They send it to the engineering team. I thought they'd have more of a thing here. Yeah, so whatever, it's the steepest learning curve. They'll send those designs to the engineering team, and then they'll actually create that website or app or whatever. There's this other one called Lucid Chart. This is a little bit more user-friendly. Depending who you ask, it's not as good. There is Miro. I'm going to just kind of throw this out now. I'm going to recommend that everyone does some sort of trial and error to find the one that like fits with you. But Miro is absolutely the easiest one to use. My biggest problem that I personally have, I don't know if you guys noticed that everything is like pitch black on my computer. That's my preference, dark reader and dark mode on everything. And with Miro, it kind of like, I don't know, it just kind of doesn't work. The dark mode, like overriding it, and they don't have their own native dark theme. So like, that's my biggest gripe with it. Kathleen, you had a question?
Yeah, not a question. Just I prefer Lucid Chart specifically because it keeps everything in your memory, right, like on your disk. And so that's one of the few things since I work for like government clients and stuff. So you don't save anything to like their server or anything. It saves it all on your disk.
Oh, that's really cool. So it's kind of like a hybrid local in terms of where it's saved.
Yeah.
I didn't know that. That's really cool.
Yeah, and it's flexible enough that I've created because I've used that for ERDs, and that's been the best one for me personally.
Okay, right on. That's cool. Thanks for sharing that. There's this other one. This one's been around forever. It's not even called Draw.io anymore. just kind of there for legacy. I mean, that one's all right. But like I said, a lot of this is just really preference. But I would recommend go through and play with it. And even today, if you like finish quick, or if you're using one and you get a little frustrated, just kind of switch to another one, see if it works better for you. I added this one to the list today, Mermaid. This one's actually declarative. So like instead of like dragging and dropping, you're actually coding. You're just kind of coding it. So like the reason I like it, to be honest, is because if I'm like powwowing with like AI, I'll just be like, hey, like I'll just powwow with it and I'm like, hey, write the code, you know? So instead of having AI like make this crude diagram, which it can't really do well, I still don't like its images capabilities. Instead, it can just kind of generate the code. So for me, that's kind of like a little lazy way to do it. But it's very like stiff because it's all code. You can't like move things around or resize things like it. Well, you can resize, but you can't move stuff around to get that diagram like mock-up. So this one's not for everyone. And then we actually do have here, if you do like that concept of declarative diagramming, there's actually a link here and it has a bunch of different options. But this is the one that I've used, so I put it on the list here so you guys can see it. So here's the thing, we do have some time, not much time, 20 minutes. I'm going to show you guys Miro, and we're going to use this as a starting point. So we're not going to do anything super crazy. I'm just going to kind of just show you the UI real quick for at least Miro. The biggest takeaway, why do I always have to sign in? The biggest takeaway is just kind of like seeing the concept and like, you know, knowing that you got it. Did you guys see what I'm talking about? When I said about the dark theme, like it just, but if I refresh, check this out. Oh, hold on, that Zoom UI is in the way. All right, I got my daily blast in the face today.
Yeah, it picks you up on camera. The screen change.
Yeah, because
There's
there's like
people though, man. There's always those people that screen share their white screen right at everybody.
yeah, you know what? I'll be honest, man. Not like I said, we only got 20 minutes, but like I hate that the light theme is the norm. It kills my soul. And I wish that's like my biggest thing I'd like to see change in the world. Like some people want world peace. I just want standardized light mode. Oh,
As
okay.
programmers, you figure that's what the default would have been. But then you can tell that advertising got in and was like, no, people like white.
People like white. That's deep.
Whoa, I mean, you know what I'm saying. You know, on a visual UI, text, whatever.
So here's what I'm gonna do. So I hit the create new. Oh, my eyes are still blasted. I was a combat engineer, so my eyes are like, they don't like that bright flashes. All right. Anywho's, let me move this out the way real quick. So, okay, here's Miro. This is like the easiest one to use. So essentially here, we got shapes. You see how it will never pick up the dark mode here, but we're just gonna put it here. And then one of the things we're going to do is, right, this will be more of the highest level, right? So let's say we did, here's the client and the web browser. We could do something like that. One of the cool things you can do is like here in the search bar, I typed in user. Bam, look at that, right? There's no rules here. The only rule is that you follow like the design trends of like consistency and clarity and whatever and readability. So you could do something like this. You can do something like that to kind of illustrate, hey, there's human involved for people who don't know. Sometimes I think this has it, if I'm not mistaken. Let's see. See, one of the things I don't like about Miro is a lot of their stuff is paywalled, but I'm pretty sure they have something. I think I used it earlier. Oh, wow, is all this paywalled? Hold on. All right, whatever. So sometimes they have like shapes of computers on some of those alternatives. They're not paywalled, so you can have access to everything, right? But let's say we have this client browser, right? So let's just go ahead and copy and paste this, slap this over here. Let's say we're going to get to Route 53. One of the cool things about this is like a lot of the other ones, you have to like go into shapes and find an arrow. For this one, if you click on it, you have these blue lines. I can actually just draw right here. So it's like, it's super clean. It's definitely a time saver. What's going to happen here though, and oh, actually this is another thing too. You see how that arrow moves with it? A lot of them don't do that. So like if you move a component, then you have to move the arrow separately. So I just like I said, this is probably the best one minus their UI issue, or what I call a UI issue. I'm going to move this arrow over. Sometimes it gets a little tricky. You can zoom in, and then I can move this. And the reason I did that is because I'm going to create another one here. Here there's a giant T. I'm going to click it. We got a text box. And then what I'm doing right now is just essentially kind of like what we talked about, right? But I'm showing you, if you hit function and up, you can change the layer. You can't tell because there's no styling. So we're going to add some styling here. For this floating text, I'm just going to add some sort of a background. That should have worked, actually. There we go. Since I have that on here, I'll make it a little bit larger so you can actually read this. I'm going to copy this over just for text. I did just Command C, Command V for copy and paste. I'm sure you guys are familiar with the shortcodes. All right, cool. So from the client browser, we're sending the DNS query to Route 53, and we're getting back the IP address. However, you may notice something's wrong here, right? We got both of these arrows pointing down. If you click on this arrow here, the UI is a little weird at first, but here on the left side, how it says none, and on the right side, there's an arrow. You can literally change that to an arrow. And then here we can change this to none. So let me see if we can move this over a bit so you can see. Oh. You do have to hit that little blue dot. I'm not sure if there's any Miro experts. I'm not a diagram expert. Maybe there's an easier way. But see, now we actually have the right flow, right? The DNS query is going to Route 53, sending us back the IP address. Then essentially what you want to do is kind of like prettify this a little bit. You can just click on here, click on the background color, choose whatever. Doesn't matter, it's all made up. You don't need a background color. You can keep everything blank. But just as we said, there's no rules. One of the things I would recommend, here I'm going to copy and paste. What I would recommend is when, at your company, kind of check what the standard is. Like take a look at other docs, see what other people are doing. That way, you're just kind of following the norm. And if it's like a lo-fi environment, it's just a lot simpler to just kind of create these lo-fi things instead of trying to like color them and make them all pretty and stuff or whatever. So then from here, we have this additional flow. And then here I'm going to add this arrow. I'm going to copy and paste this text. And then here it's a request. So essentially this here, well, let me ask, just in terms of using this UI, does anyone feel like they either learned something, from this like quick little demo, or does anyone feel like they absolutely can't do this?
It seems like it will be time consuming, but it definitely seems possible at least.
I do agree with you. I think it's a lot more time consuming than it should be. That's why I use that mermaid one. Because like I said, I'll have AI, but that's if I'm already talking to the AI, like kind of just powwowing. And then I'll be like, hey, based on this flow, can you create whatever, and it'll create the code. But yeah, I absolutely agree with you. It is possible though, because there are a bunch of keyboard shortcuts, and I was going to try to learn them before, but look at the UI. So I can't see it here because of my dark mode. I'm sure with the keyboard shortcuts, it's probably a lot faster once you find the one you like and if you decide to master it. Aside from that, though, I mean, this is kind of the whole shebang here. Of course, this is like the highest level one, right? As you get deeper, things become more technical. And like you said, you want to talk about time consuming, this is the easiest one right here. So as we go on, it's going to be, a lot more time and effort involved. So yeah, this is, essentially it. So like the diagram is something that like is very important because you need to communicate processes. The concept of creating a diagram is very simple, just kind of making shapes and like showing flow. You can use this for anything, showing user journeys. Like even if you're a front-end engineer, if there's a new feature you want to implement or a new way to change the feature, diagrams are really good. I've noticed in my career, I don't know if it's different for anyone else, I noticed that the people that are more experienced are better at making diagrams. I don't know if I just told you how terrible I am. No, I'm kidding. I'm actually really good with design, system design, just not taking the time to map it, because maybe I'm a little stubborn, but I kind of also feel like, hey, dude, just check out the code. But that's not the right attitude to have, so don't be like me. Instead, get better at these diagrams. One of the other things I can show you too, real quickly. Let me go back here. So I did this one earlier. I was playing with this. Yeah, I mean, this is essentially the same thing that I just did right now. The only thing is, it's just a little cleaner because I had more time to play with it. But yeah, so this is the context example. Same thing here. So then I created the container example. So this is the same thing you had saw lo-fi that we already described. But, I mean, that's really it. It's one of those things like it's simple, but it's not, especially if you don't do it right. But just whenever you create it, just try to think of it in the sense of like whoever is your audience. Just kind of think of it like if you were building an app for a user, right? But instead of building an app, you're showing a visual representation of something, of a process, right? And instead of a user, it's a coworker or stakeholder, but just kind of do it where it's like a user-focused system where even if you don't like it or you think it's tedious or whatever, just know that it's not for you, right? It's for the person that you want to convey the information for, which is just that whole thing, right, with the dogs in the cage. So don't create a diagram that's going to be a barrier to that communication. Use it so it's that open gate. Yeah, no, that's essentially it. So let me show you guys this assignment real quick. That's strange. Let me see here. Go back one more. Cool. So here for the assignments, C4 model diagram. What you're going to do is I'll click on this and there's 3 diagrams that you're going to make. I'm going to ask that each student give feedback for at least one other student's diagram. So there's 3, but just one of them, right? And each student should receive feedback from at least one other student. The reason that's important is because remember with these diagrams, they're living, breathing documents. And when you show another student, they might say, wait a minute, is it like, am I missing something? Or is it not, or whatever. So you can kind of get that real world feedback and seeing if it conveys as well as you think. And if not, if you can add something. Yeah, right here, there's just 3 different ones. The first one's going to be routing IAM policies in a permission diagram. It's going to be a full stack application diagram. And then the third one should be the most fun. It's pretty much like whatever like custom app you want. So you get to like create your concept of an app on whatever like level or whatever, and then convey it. I would say if you're going to have someone review one of them, maybe have them review this one because these 2 are kind of already laid out. Whereas this one, you're really expressing a unique idea that the person reviewing has no concept about. So it might be the best in terms of getting feedback. So yeah, that's it. I'm gonna let you guys, I'm gonna open up these breakout rooms and then you guys can rock on the assignment and then I'll pull you back in 30 minutes before the end of the class so we can demo this stuff and talk about review if it was as easy as you thought, if not, whatever.
Jonathan,
Oh.
just quick comment.